Can colorimetric biosensors monitor glucose levels? Have you ever wondered how technology can help manage health in a simple and effective way? One exciting development in this area is colorimetric biosensors. So, can these devices monitor glucose levels? Let's break it down. Colorimetric biosensors are fascinating devices that detect glucose by changing color. When glucose is present, these sensors use chemical reactions to produce a visible color change. This color change indicates the concentration of glucose in a sample. These biosensors are part of a larger movement in biotechnology and nanotechnology. Advances in these fields are making medical diagnostics more accessible and user-friendly. For glucose monitoring, enzymes like glucose oxidase and horseradish peroxidase are commonly used. When glucose interacts with these enzymes, it leads to the creation of a colored compound. One popular compound produced is oxidized 3,3'5,5'-tetramethylbenzidine. The intensity of the color can be measured visually or through a smartphone camera. This combination of chemical sensing and everyday technology is a hallmark of modern diagnostics. There are several practical forms of colorimetric glucose biosensors. Some are wearable devices that attach to the skin to monitor glucose levels in sweat. These devices use microfluidic channels to collect sweat, which reacts with color-changing chemicals. Users can read the results directly or capture them with a smartphone for analysis. Another option is paper-based biosensors. These small strips are treated with chemicals that change color when they come into contact with glucose in fluids like tears or sweat. They are low-cost, disposable, and perfect for point-of-care testing. From a technology perspective, colorimetric glucose biosensors are appealing because they are simple to use. They do not require complex electronics for detection. Basic image capture and processing, features found on most smartphones, are enough. This simplicity makes them great for remote monitoring and personalized health tracking. However, there are some limitations to consider. Colorimetric sensors generally have higher limits of detection compared to electrochemical sensors. This means they may not be as sensitive at very low glucose levels. Factors like lighting conditions and sample volume can also affect their accuracy. Despite these challenges, research continues to improve the sensitivity and reliability of these sensors. Often, this involves combining nanotechnology with advanced materials and better signal processing methods. In practical terms, colorimetric glucose biosensors are being tested for non-invasive monitoring. This means they could eliminate the need for fingerprick blood tests. They show promise for continuous glucose tracking, especially for those who find traditional methods uncomfortable. As technology advances, these sensors could become even more accurate and user-friendly. This could blur the line between medical devices and consumer technology. In summary, colorimetric biosensors can indeed monitor glucose levels. They offer a visual, low-cost, and user-friendly alternative to traditional methods. Their integration with everyday technology positions them as a valuable option in the growing field of wearable health technologies. While they may not replace all clinical glucose monitoring methods, they representing a meaningful step toward more accessible diagnostics.